Hi everyone, my name is Sundar Sheikh and I'm your STEAM ambassador today. I'm currently studying at Pasadena City College. I hope you all are doing well. Today we are going to do a workshop that named as The Chemistry Behind Rain and Hot Ice. So I hope we all enjoy it and we all do it together. What is the goal for today? So, what are we going to learn today? We are going to learn about chemical reactions and its types. So, the two types are endothermic and exothermic. We are going to learn about the formation of rain through condensation and the concept of crystallization. So, let's go over today's agenda. So, first of all, I'm going to introduce myself so that you guys get to know me well and that you can relate with me. Number two, we are going to learn about chemical reactions and its types, as I just said, exothermic and endothermic. Then we are going to learn about the formation of rain, so how rain forms and what's the concept behind it. And in number four, we are actually going to do an activity. We are going to make it rain. Then we'll come back from the activity and then we are going to learn about hot ice, which is a really interesting concept. And we are actually going to make hot ice. So that's really interesting. Then I'm going to tell you how you can try something with your friends. And then we are going to wrap it up with the applications. So let's just get started. Let's have a little icebreaker here. So, this is me, as you can see in the picture. My name is Sundar Sheikh, and I'm a biochemistry major. I'm currently studying at PCC. So, here I have some questions that I hope would probably help you guys get to know me a little bit so that this workshop would get a little bit fun. So, I would like to start on by asking you guys, how's your quarantine going? I hope you guys are all staying safe and practicing social distancing. I know that it's like quite a while now that we are stuck at our homes and that it's really hard to be positive and productive at home. But I would really like push you guys to try your best. It's okay even if you're not having a productive day. As long as you're having a day, that's completely fine. Then you guys might have the question that like how my quarantine is going. So basically I'm just doing a bunch of homeworks because I'm currently taking a lot of classes in my college because I'm transferring. So I have to complete some units, so I'm doing that. Um as I've told you guys before that my major is biochemistry. So why did I choose biochemistry? I want to tell you guys a little bit about it so that you guys can relate, as many of you might have been thinking about what you guys want to do in the future. Um, Throughout my high school, I've always loved biology. I loved like knowing more about organisms. I loved like knowing different parts of the body and everything. And it was always my thing that like, oh, I'm going to do something with biology. So when I first transferred to Pasadena City College, I chose biology as my major. I never liked chemistry, maybe because I was never introduced to it before. And then during my first semester, I had to take a chemistry class as it was part of my biology major, and I instantly fell in love with it. I liked like how there is always like reason behind like normal things that we do, and that how everything goes. There are reactions and how molecules react and everything, and it was really fascinating to me. So I decided to choose biochemistry as a major because in biochemistry you learn about the chemical reactions or the chemistry of a human body or living things. So this really like helps me combine both of my interests together. What are some of my hobbies? The thing that I really like to do in my free time is to like run while listening to music. I think it kind of takes your mind off from your daily stuff that you are being constantly engaged with, and it helps me a lot to clear my mind and to think more productively. Other than that, I love reading. I feel like reading makes you more knowledgeable and also it makes you more sophisticated when you talk to other people. um One more thing that I really like is cooking or spending time with my mom is just like something that really relieves me and makes me stress free. And I would really recommend you guys to do that as well. If you have some time and you think you have nothing to do, instead of like being on Instagram or mindlessly scrolling through it, I would suggest you to like go and spend time with your parents. It's actually really refreshing. Um, what are some things that I like about PCC? Something that I really like about PCC is that the community is really good. You kind get to enjoy a lot. You get to meet people that have similar interests with you, and it's not all about studying. You get to have a lot of good experiences, and the professors are really exceptional here. So PCC is like has given me some of the best memories. Let's now get into the um, bulk behind this workshop. So, first of all, I want to make you guys learn what are chemical reactions. In order to know what are chemical reactions, we need to know what are reactants and what are products. For some of you, it might be new terms, so let's dive into them. Reactants simply means substances that react, and products means substances that form. So if you see here, reactants means the substances that react to form the product. So if you have two things, let's just say you're going to make ample. If you want to make lemon juice, so let's just say you will have lemon and then you would have water, and if you want sugar, you can have sugar. These are all the reactants, and when you put all of them together and mix them, and the final thing, that's called the product. So reactants are like the initial things that you have, and products is like the final thing. Now, what does this has to do with a chemical reaction? A chemical reaction is basically a combination of two reactants to form an entirely different product. So as if you can see here, how is water formed? You have hydrogen, you have oxygen. These are the reactants and they make the product, which is water. In a chemical reaction, when two substances are combined, change occurs and something new is formed in the process. So, in a chemical reaction, you're not going to end up with the thing that you have started. So, like if you're making lemon juice, you're not going to end up with a lemon. You are going to take two things, and in the end, a new thing would be formed. As you can see here, we have a hydrogen molecule, we have an oxygen molecule. They reacted, and the water is formed, which is completely new thing. So, what are some of the examples of chemical reactions in daily life? So, as you can see, cooking an egg, it's a chemical reaction. Baking a cake, fireworks, as you have always seen, like you start with something and reaction happens and you see a lot of fireworks. Vinegar and baking soda mixture, that's we are going to do today. So, you guys will learn about that. Burning of wood, when you burn the wood, it's actually a combustion reaction, which means that a reaction that involves oxygen, and as a result, carbon dioxide and water is produced. Metabolism, the reactions inside your stomach or when you digest something, the reactions that happen, they're also called chemical reactions. So these are some of the reactions, examples of the chemical reactions in your daily life. So, in a chemical reaction, as I've told you, that reactants react to form products, it, it is certain that we are forming a new thing, but we are just converting one thing into another thing. We are not actually creating something or is actually destroying something. Why? Because of the law of conservation of energy. What does law of conservation of energy means? It means that energy can neither be created or destroyed. It is just transferred from one form to another. So it basically means that the energy remains constant. You are just changing its form, its shape, or the way it works. As you can see in this picture, there are some energy transformations. For example, if you eat something in the food, there is chemical energy. That energy gives you the ability to move and do work. So that chemical energy is transferring into something that will help you work. In the same way, energy from the sun, it helps the trees do photosynthesis. So it helps the trees gain energy for their own nutrition. So that energy from the sun, solar energy, is just being transferred into the chemical energy. Here, the energy from the fuel, which is the chemical energy, is helping the car to move, which is kinetic energy. And you can see here also in this example, in the picture, the electricity is being given to the bulb. Some of that energy in the electricity, electrical energy, is helping the bulb to light up, and the rest of it is just being transferred as heat. So the energy is being transferred. It's not being created. Like here, I'm not creating anything. I'm just converting the energy of the electricity, like the electrical energy, into light and heat. There is no creation, and neither am I destroying everything. So the energy remains constant. If you see here, the apples on the tree, the apples are stuck to the tree, right? This is the potential energy because of height. And as soon as the apple drops, it converted into the kinetic energy, which is the energy due to the motion. So energy is just being converted. Law of conservation of energy is basically is you cannot destroy something or you cannot create something. So law of conservation of energy basically is that energy can neither be destroyed. So law of conservation of energy basically is energy can neither be created or destroyed. You are just transferring energy. So now let's look at what are endothermic reactions. Endothermic reaction is a reaction that absorbs heat from the environment. So what does that mean? Well, endothermic reaction is a reaction that absorbs heat from the environment. And when the heat is absorbed from the surroundings turn cold. As you can see here, this is an endothermic reaction because this is absorbing heat from the environment. And if you're absorbing heat from the environment, then the surrounding would not. So, as you can see here, that you are absorbing heat from the surroundings. So, when you are absorbing the heat from the surroundings, there would be no heat in the surrounding. So, that surroundings would be just get cold. What are some of the examples of endothermic reactions? Melting ice cubes, evaporating liquid water, cooking an egg, baking a bread. How are these endothermic reactions? Say you take some ice and then you put it on the table. As you put it on the table, why do you start feeling cold suddenly? What's happening? The thing that's really happening is that ice, it's absorbing the heat from your surrounding. So your surrounding is turning cold, and that's why when you have ice near you, you started feeling cold. Other examples are evaporating liquid water. When the liquid water evaporates, it absorbs heat from the surroundings, and that's why the surrounding gets cold. Cooking an egg is another example of that, and baking a bread. Baking a bread actually it is taking so when you bake a bread, you put it in the oven, it takes the heat from the oven, and because of that, the surroundings of the oven turns cold. But for sure you cannot experience that because you're not in the oven, but it happens. So the endothermic reactions happens there. Now let's move on to the exothermic reactions. So we know that endothermic reactions are the reactions that absorb heat from the surroundings, and as a result the surroundings turn cold. So any ideas what are exothermic reactions? So, exothermic reaction is just the opposite of endothermic. So, the reaction that releases heat into the environment. And when the heat is released into the surrounding becomes hot. It's like when you are giving heat to someone, that thing it's gonna get hot. So, as you can see this boy right here, he's rubbing his hands. As a result, the heat is going to be produced. That's what you usually do in the winter, right? You rub your hand real fast so that heat is produced and your hands get warm. If you look at this picture here, this picture, as you can see, it is releasing heat into the environment. And that's why the environment is getting hot. So it is exothermic reaction. Exo, you can relate it with exit. So it is releasing something. Let's just dive into the examples. What are some of the examples of exothermic reactions? They are burning of the candle or burning of the sugar, as you can see here, freezing of water into ice cubes. So melting was endothermic. But if you are freezing something, that is exothermic. And then burning of woods to make fire. As you can see here, they are burning the woods, and when you burn the woods, what you are basically doing, you are releasing heat into the environment. That's what we do when we are in the winter, right? We When it gets so cold, we usually have so many woods, and we try to make fire so that like we started getting hot. So these are the examples of exothermic reactions. Now, after we have learned about endothermic and exothermic reactions, now let's learn about condensation. Many of you might have a slight idea about what condensation really is, because when you learn about different states, freezing, melting, boiling, you learn about condensation as well. But it's not really talked about as much, so let's just go into it. Condensation is a process through which the water changes from the gaseous state. So, gaseous state really is water vapors to the liquid state, meaning liquid. Basically, it's the reverse of evaporation. So, what is evaporation? Evaporation is when the liquid turns into gas, simple, boiling, right? But then now, when you're turning gas into liquid, then that's condensation. As you can see here, the water vapors are being turned into the liquid. So, this is condensation. You might have seen this in the morning, or like when you like when it rains. You might have seen this when it rains. So here you can see, now I'm going to tell you that how does rain form. So we have learned about condensation. Rain forms through this water cycle. So what is this water cycle? Rain basically is the droplets of water from the clouds, right? So what happens is like heat from the sun turns water from plants, leaves, oceans, lakes, and rivers into water vapors, which disappears into air. This is called evaporation. The vapor then condenses into tiny water droplets, which form clouds. When the droplets gets too large and heavy, they fall as rain. This is precipitation. Then these these rain droplets, they get accumulated in the ocean in different places where there's water, so there's a collection, and then the same thing happens. So this is the water cycle. So it goes on and on and on. So first evaporation happens because of the heat, then the condensation happens where vapor turns into liquid, then you have raindrops, and then these raindrops get accumulated and the cycle goes on. Now we have learned about the water cycle, so we are going to do the first activity, which is let's make it rain. In this activity, you're going to form rain because of condensation. When the water vapors from the hot water in the glass comes into the contact with the coldness of the plate, condensation happens and the water vapors are turned into liquid and fall down as rain, as you can see here. So we are going to do this activity. So the materials and steps you will need would be a clear glass of water, some ice, and plate. Steps would be, first of all, you're going to warm the glass of water in the microwave for about 2 minutes. You're going to place the ice on the plate, as you can see. You're going to cover the glass of water with the plate that has the ice and let the rain happen. But before we're going to do this experiment, we're going to have some lab safety rules. As we all know that it's important to be safe. So first of all, you guys might have should be dressed appropriately. You should not have cell phones near you. No food. You should have your proper supervision, so parents should be around you when you're using, because for this one we're using microwave, and for the next experiment we'd be using stoves, so you would need your parents help. You should clean up, um, and most importantly, don't get distracted. Focus on the experiment and get help from your parents. So, my name is Sundar Sheikh, and I'm a biochemistry major at PCC. This is my second year, and hopefully, I'll be transferring this year. Today, as we have just discussed it, we are going to see how rain forms. So, the concept behind the formation of rain is condensation, and condensation is when the gaseous state of the water, which is like the water vapor, it turns into the liquid state. So we are going to see the actual demonstration of it and we're going to make it rain. So let's make it rain. So the things that we would be needing today is some ice in a plate. You can take any plate you want, and how much ice you want just depends on you. We need a jar. You can take any glass jar that you have. I took this one. It's like a decoration piece at my house. You can take any glass jar. You just have to see the demonstration. You can see through it. And then a glass of water. So what we are going to do, we are going to take this water that I have and we are going to put it in the microwave oven. So the water is being hot now and you can see some little steam. Steam is going there as well. So we're going to put this water and we are going to put this inside this jar. So you have to be real careful when you're doing that. There you go. And then we are going to put this plate with the ice, just wait for 1 second, on top of this. Then we are going to see the magic happening. You're gonna see some rain forming, some droplets, and then the rain would form. So let's just wait patiently. As you can see, the steam is being cooled down, and if I just gonna close it real quick, you can see some water vapors here. And this is what happened when the droplets form. You can see it now. See the droplets getting formed here? That's how like the little drops of rain when it falls onto the ground happens. And you can, if you can closely look, it's the same thing going on here. So it is actually raining inside. It's like, this is how it rains. Like, you can see the drops. You can actually hear it if you can. And if you look at here, it's actual like drops going down. So this is how the rain forms and this is how the rain works. You can actually hear the voice of the rain, the sound, if you hear closely. See the water droplets here? So the source of heat here was this hot water that we had, and that hot water, it absorbed the heat, so it turned into the vapors, and then with the source of the ice that we had, it cooled down and then condensation happened. So water vapor, it changed into the liquid. So that's how the rain happens. Hope you guys learned anything. How do crystals form? Now, Now, after we have come back from the experiment, how do crystals form? What are crystals? Crystals are formed when liquid begins to cool and begins to harden. During crystallization, atoms arrange themselves in an organized form. They occupy less space as compared to their liquid state. So, this is the gas phase. Now, when you are in the liquid phase, the molecules are a little bit together. So, you can see in the gas phase, they are randomly apart. But when the liquid phase, they get a little bit together. And then when you are crystallizing them, they get arranged in a really proper form. And that's called crystallization. So why I have taught you crystallization, it's because we are going to do our second activity, which is let's make hot ice. So in this activity, the hot ice is formed due to the exothermic reaction. Remember, exothermic reaction that releases heat. When vinegar and baking soda are mixed, the solution of sodium acetate is cooled below its melting point and the liquid begins to crystallize. The crystallization is an exothermic process, so the resulting ice is hot. So the materials that you would need aluminum foil, tablespoon, vinegar, baking soda, cup to measure, some heat source for basically would be oven, cups and plate to transfer and demonstrate, and bowl or pan to cook. So let's see what are the steps. So before we go into the steps, let's just reinforce adult supervision and safety procedures. So please don't try this without any supervision. It is safe, but still parents should be there. You should not try it without your parents. No food. No, you should be away from the hazards. Clean up everything. Handle glassware carefully. And also like the hot glassware. So when you're heating something, wear gloves, dress appropriately, and no cell phones around you. Be attentive. We are doing an experiment we're doing at home. So even though it's safe, still be attentive. So what are the steps for making hot ice? First of all, we're going to add 4 cups of vinegar and 4 tablespoons of baking soda slowly to a bowl. Then we're going to heat the solution on a stove for about an hour or so until some particles of white powder are being observed. After that, we're going to pour the liquid into a glass or cup carefully and cover with aluminum foil. Put the covered cup or glass in the freezer for about 45 minutes. Then we're going to scrap a few crystals from the sides of the bowl of heating pot onto the plate. We're going to take the liquid out of the freezer, pour it slowly on the crystals, and we're going to enjoy the hot ice formed. To put the vinegar, almost 4 cups into this pot. So I'm going to do that right now. So let's just do this together if you're doing this experiment with me so that it's more fun. So I am going to pour vinegar here. This is 1 cup. The smell of the vinegar is kind of like, if you don't like it, it's okay. So after I have put 4 cups of vinegar into my bowl, now I am going to put in baking soda. So 4 cups of vinegar, and then we're going to have 4 tablespoons of baking soda. So I'm taking the baking soda. This is 1 tablespoon. So it's not a trick, but it's highly recommended that you are putting this slowly, because just see right now, if I'm putting this, there's going to be a reaction like this. The sodium acetate is being formed, and if you don't want to spill this all over your table, it's highly recommended that you do this slowly and as patiently as possible. So this was my first one. I'll put more. So this is going to be my second one. Just like when you open a soda and all this kind of things pop out. Look at this. It's like you can use this as a foam and play with each other. This is my second one. See how much it is being risen? Like how much it's going up. Like you can easily spill this. Like, okay, look at this. It's so foamy and all. It's like sodium acetate. So vinegar, which is acetic acid, and baking soda, which is sodium bicarbonate, it reacted, and now we have sodium acetate, which is this kind of like reaction going on. So this is my third one. I'm gonna put my third one now in. So this is my third one. I hope it doesn't come out that much. Okay, let's just see. Now this is going to be my fourth one. So this is my fourth one. I put this all in. So I'm let it. I hope it doesn't spill that much. So mine one doesn't spill, but I would highly suggest to put it as slow as possible. So because you can see that how much it rises. So this could literally spill on your tablecloth or anything that's like really useful for you. So after we are done with this, I am going to put this on the stove, but before that, I am going to mix it. You can stir it as calmly as possible so that everything gets dissolved. All the baking soda and the sodium acetate gets dissolved into each other. So now we have sodium acetate, which is basically we have vinegar and baking soda in this. But in order to make hot ice, we need a concentrated solution, a supersaturated solution, which means that we need a lot of, we don't need a lot of things that's inside it, like it's really dilute. So let's just make it clear that, like, for example, if you have like a drink you're trying to make, let's just say lemonade, and you put in lemon and then you put in a lot of like water, it's like a dilute solution because it has a lot of water and a lot of lemon. But then if you want to make it concentrated, you can boil some water and you can have like a little bit of that solution left, which is going to be called concentrated. When solute is more than the solvent, it is concentrated. So for this one, we are having a dilute solution right now, so we need to concentrate this in order for the crystals to form. So let's just do that. I'm going to put this on the stove. So now I have put this on the stove. So you don't have to have like a lot of heat, like it's a little bit less than high. So I put this on that. And for this one, now I have to wait. So what I have to wait for? I have to wait for the crystals forming all around this pot, and the thing that's inside it, which is vinegar and the baking soda, the solution of that to evaporate. What I'm doing this for, I am doing this for to make it more concentrated because it's dilute. So let's just wait and see the crystals forming. So as you can see, the crystals forming all around the pot, and it has been boiled, it has gone concentrated. So now we are going to put this in the glass that we were going to put this before. So I'll see you then. So I have put the liquid into this. So it's, if you can see it, it's a pale yellow color. I don't know if you can see it properly or not from here. Now I'm going to put the foil on this. So after putting it in this glass, I have covered it with the aluminum foil, and now I am going to put this in the freezer for almost like 1 hour. So I'll get back to you after that. So this is how the pot looked after I have taken out the liquid from it, and now I'm going to scrape some of this. You can use a spoon or anything to just like scrape it, and I'm going to put some of these crystals into this plate so that we can speed up the process of crystallization when you pour the liquid onto it. Okay, so let's do that. So this is how it looks like after I've taken it out of the freezer. I don't know if you can see it, the liquid inside. Mine is a bit discolored, and it usually gets discolored when you heat it a lot. So now I am going to pour this on this plate where I have some crystals that I scraped off from the pot. So we need these crystals because the crystallization process, in order to drive it forward, we need some crystals on the plate so that the ice could form. So I'm going to put this little by little onto this. You can see the ice forming. Look at this. You can, and if you touch this, it's hot, like it's warm. It's not really hot, but it is warm. And it depends on how much liquid you have. If you have more liquid and the way you spit it, you can make a tower out of that ice crystal. But this is how you make the ice here. I hope you enjoy this experiment. So some tips for this experiment. Add the baking soda slowly to the vinegar. Like I've said before, if you add it fastly, it's just gonna make reactions and everything is just gonna get messy. Make sure that sodium acetate solution is boiled properly. So if it's not boiled properly, then your ice is not going to be formed. So wait properly until it's boiled. And secondly, if the ice does not form in the first attempt, that means the solution is not boiled properly. So put the solution back into the bowl, boil it again, and do the process of forming the ice again. So if in the first attempt you take the glass and then you take the liquid and you try to make the hot ice and it is not formed, boil that liquid again and then do it again so the ice would form. So now we're gonna have a challenge for your friends. So the challenge is called Who Can Make the Highest Tower? You can keep on repeating the hot ice experiment and build a tower of hot ice. So what we are gonna do, so the challenge is you're gonna challenge your friends in this quarantine and see who can make the highest tower. You can as well add a food color of your choice and make a colorful tower so that as you can see here, towers like these. So you can make different shapes out of it and then you can share with each other who has the highest one. Now, some of the applications of this hot ice, you might be like, oh, we're just doing this experiment. Where is it used? Like, does it has any use, any significance? Yes, it does. The real world application of this process is hand warmers. Hand warmers as well utilizes the concentrated solution of sodium acetate. So, like what we made with the combination of vinegar and baking soda. And the process is similar to crystallization. When you rub it, the same thing happens. They both react and then because it's an exothermic reaction, you feel hot because the heat is being released. Now, let's just have some knowledge about biology and chemistry. So, what is biology? Biology is the science that studies life and living things and the evolution of life. Living things includes animals, plants, and fungi. What is chemistry then? Chemistry is the study of matter, its properties, how and why substances combine or separate to form other substances, and how substances interact with energy. So, biology basically relates to life and living things, and chemistry relates to different reactions, the properties of them, and the study of how different substances react with each other. Now, career interest, as I've talked about biochemistry before, let's let's see why biochemistry is interesting. So, what is biochemistry basically? It is a branch of science that explores the chemical processes within and related to living organisms. It is a laboratory based science that brings together biology and chemistry, as it says in the name, biochemistry. By using chemical knowledge and techniques, biochemists can understand and solve biological problems. So I choose biochemistry because I like both biology and chemistry. So if you are like me who likes both biology and chemistry, then you should as well choose biochemistry. So you can be like, what I can do with biochemistry? Be like, okay, Sundar, you told me I should be a biochemist, and what am I going to do with that degree? So you can do a lot of things with those degrees. You can become a college professor. You can become a physician. These are the most common ones. You can become a biochemist. And then the special ones are you can become a pharmacist because you know different reactions. You can become a forensic scientist. You can become a food scientist. And other ones are you can become a medical lab technologist, high school teacher, toxicologist, and the non traditional ones are biomedical engineering, science journalist, or biotech representative. There are a lot more that you can do with biochemistry. So, like if you like being a teacher, go to that route. If you like applying it, you can become a pharmacist. You can work in a lab, like lab technologist. And then, if you want to go more and expand more on that, you can become a physician. So now we are going to wrap up our workshop. I hope you guys learned a lot. So today, let's go over what we learned today. So we learned about chemical reactions, exothermic and endothermic, how rain is formed through condensation, and how to make hot ice. I hope that you guys had fun doing these experiments with me and learning about them, and they make you feel fascinated as it does to me. I hope you guys again are all staying safe and being positive during this quarantine. So thank you, and then I hope that you learn a lot.